We are in section 7.2, multiplying powers with the same base. Now, I don't know if your other teachers told you, but you hold the base at the exponents when you're multiplying. So what's the expression written using each base only once? So we got 12 to the 4th times 12 to the 3rd. Now remember, hold the base at the exponents. So equals 12 to the 7th. Do not multiply these two, we are adding, right? So same thing with a negative one. Negative 5 to the negative 2nd times negative 5 to the 7th. You're going to do negative 2 plus 7. So that's going to be negative 5th to the 5th power. All right, so try letters A and B. All right, so for this problem, I want to know what is the simplified form of 4z to the 5th times 9z to the negative 12th. All right, so the book shows you a little bit differently. All right, so these are both z's, right? Both z's. So now what I want to do first is I want to multiply my constants together. So I'm going to do 4 times 9. I'm going to multiply that by z. Now, z to the 5th times z to the negative 12th. All right, so 4 times 6 is 36 times z to the, remember, hold the base at the exponents, plus negative 12. And that's going to be 36 times z to the negative 7th. Now remember, what is raised to the negative power? Only the z. So when we simplify it, it's going to be 36 times z over z to the 7th. All right? All right, so let's try one more. 2a times 9b to the 4th times 3a squared. Now remember, multiplication is commutative. So let me rearrange this. So again, let's look at everything that has an a. This has an a and this has an a. So let's do 2 times 3, which is 6, times a squared, times 9 times b to the 4th. A times a squared. If there is no visible exponent, it is just 1. So then that's going to be 6a times 1 plus 2 times 9b to the 4th. And then 1 plus 2 is 3, so 6 times a to the 3rd times 9b to the 4th. However, we are not done yet. This a to the 3rd and this b to the 4th cannot be combined, but the 6 and 9 can. So therefore, 6 times 9 is 54 times a to the 3rd and b to the 4th. And that is your final answer. So why don't you try Goddard's A and B? If you can see B, A and B. All right. Problem 3. At 20 degrees Celsius, 1 cubic meter of water has a mass of 9.98 times 10 to the 5th grams. Each gram of water contains about 3.34 times 10 to the 22nd molecules of water. How many molecules of water does a droplet of water shown below contain? All right, so each droplet of water has a volume of 1.13 times 10 to the negative 7th meters cubed. All right, so to find out how many molecules of water, you got to multiply the volume by the grams and by how much each gram contains. So this is what we're left with right here. So let's combine everything. All right, so we took the constants away and then we took everything with the same exponent. Now remember, these have the same base, same base. So therefore, you're going to multiply this number, which is 37.7. Then you're going to hold the base, add all the exponents. When you do, you're left with this. So therefore, this is your answer. So that's about how many molecules of water a droplet contains. Move this so you see. All right, so why don't you look at this this question. Now remember, this 200 is represented by the cubic meters. So what essentially is asking you to do is plugging this into here. Let's look at problem 4. All right, so let's look at problem 4. No, let's look at problem 4. Simplify the expression 81 to the 1/4 power. Now, 81 to the 1/4 power is essentially asking you, the fourth root. Now, if you take the square root of 81, that's the same as saying 81 to the 1/2 power, because there's an imaginary 2 right there. Not imaginary, we just omit it. So 81 to the cubed root of 81, that's the same as saying 81 to the 1/3 power. So what are we essentially doing is we're trying to find the fourth root of 81. And that's saying what same 4 numbers can we multiply to each other to get 81. So therefore, to solve for that, if you multiply 3 times 3 times 3 4 times, you get 81. Therefore, 81 to the 1/4 power, which equals 4, the cubed root, the fourth root of 81, that equals 3. All right, so why don't you try got it letter B? 27 to the 1/3 power. Try this one. This is letter B. All right. Problem 5 wants to simplify the expression 64 to the 3/2 power. Now, you always look at the denominator. When you look at the denominator, that tells you what root we're taking. So this is the same as saying 64 times 3 to the 1/2. So the 1/2, that means that we're taking the square root. So I'm taking the square root of 64, but I have that 3 left. So I'm taking the 3rd power also. All right, so this is what I do. Since 64 is a perfect square, I'm going to take the square root of 64 first. So therefore, I'm going to do 8 to the 3rd. So let me maybe write this. I'm going to take 64 and then I'm going to cube it. So the square root of 64 is 8. I'm going to raise it to the 3rd power, and I'm going to get 8 times 8 times 8, which equals 512. That's my answer. Now, if 64 didn't work out nicely, the square root, I would probably cube it first. You can cube 64 first if you want. So you get this really big number, and when you take the square root of that, you'll get 512. So you can do that, but it's just easier. If I want to do it quickly in my head, I would do it this way. Let's see, so 64 cubed would be, so then I would take the square root of 262, 144, and that would equal 512. So you could do it this way too. Yep, all right. So let's look at the last problem. All right, so property. If they have the same base, you add the exponents, where m and n are rational numbers. All right, so let's simplify this expression. 2a to the 1/3 times 3b to the 1/4 times a to the 1/3 times b times 5b to the 1/2. All right, now, like we did in the previous problems, what I want to do is I want to find what's my a's and what's my b's. So these are my a's and these are my b's. So let's rearrange that. So I have 2a to the 1. I can rearrange it because this is all multiplying. And multiplying is commutative. So times 3b to the 1/4 times 5b to the 1/2. Now what I want to do is multiply my constants. I'll multiply this constant first. So 2 and then a to the 1/3 plus 1/3. So I have 2a to the 2/3 times 3 times 5 is 15, b to the 1/4 plus b to the 1/2. So I have 15b to the 3/4. So now after that, I got 2 and 15, so I have 30 a to the 2/3 times b to the 3/4. I cannot combine any more because a and b are two separate bases. Oh, it's to the 2/3. Okay, the book shows you a little bit differently because this was to the 2/3, but we'll just keep it like this. All right, so try got it, letter A and B. Letters A and B. I'll write it for you. So try 2c to the 3/5 times 2c to the 1/5, and that's 1 and 2. Try n to the 1/3 times n to the 4/3. So simplify these two. This is a 5.